Welcome everyone, I am Nishit Ingu of DJ Sangvi College, SAP ID 37, and today we are going to do the sixth experiment of MCA subject. In this experiment, the aim is to generate a square wave using timer interrupts. For the second part, we will generate the square wave as well as detect input and give corresponding output. And for the third part, we will do the first two parts and we'll turn on the LED using external hardware interrupts. So now let's start with the first part. So this is the code for the first part. Here as we are using timer mode 0, so for interrupt I have taken the location 000BH, as this is what the whenever the interrupt occurs it will look in the ISR table for this location, and here I have given a code for complementing the output OP. So what is OP? So we can see here OP is equivalent to port P1.0. So port P1.0 will be complemented every time an interrupt for timer is occurred. So for timer for 0, the interrupt will be occurred whenever the timer overflows. So whenever the timer overflows, an interrupt will occur and the output will be complemented. So here the frequency for which we have to make the wave is 5 kilohertz. So the time period will be 1 upon frequency, which is 200 microseconds, and the T on and T off will be equal as it is a square wave. So T on will be 100 microseconds and T on off will be 100 microseconds. So for calculating the value for the TH, as we are using here, we are using the timer in mode 2, which is auto reload. So we'll load the TH resistor. So for this value, we'll divide 100 by 1.085 microseconds, and then we'll get 94, which will subtract from 256, which is 164, and we'll convert it to hex, which is A4. So here you can see that I have taken A2 because here the two cycles are used. So you can take out A4 also, it will not make much difference. So now let's run this code. Let's see in the logic analyzer. This is OP equivalent, so let's run it. We can see that the wave is there. Now let's check the frequency. Yes, frequency is right, 1.49, so it is correct. So now let's do the second part, which is generating the square wave and also giving an output corresponding to an input. So I will open the project for that. So in this code, the starting part is the same, which is for a timer interrupt I am complementing the wave which is the output which was in the previous. So I am complementing it, so we'll get a wave, square wave. The timer values are also the same, as the frequency of the wave is also same. Here I have taken two new variables, which is OP and in. So OP will be the output and in will be the input. So for a corresponding input we will have to give an output. So for that, after the timer code I have given this code I have added to it. So we can see here, if the bit in 1 is set, will not JB means if in is 1, then we'll skip this. If it is not 1, then we'll execute this and again go to hold. So from the for the skip code, we'll see that we are clearing the output, and then SJMP hold, which is again we'll go to hold, so we can get the state. Now let's run this. Let's check stop, and let's first check the frequency. It is around 500, so it is correct. Now to check if our corresponding output is generated, we give our input in P1.2, which is this, and we'll get a corresponding output in P1.4, which is this. So now for here it is 1 and it is 0, so which is right, which was our code. We can say it is 0. Now we will start this again, and now we'll see that whenever I give here 0, we can see that it goes 1, which is correct. So we are doing two things at the same time using interrupts. So this is the use of interrupts. With interrupts we can do multiple things at the same time. We do not have to wait for which we needed to do in the polling method. So now let's do the third part, which is 1 minute. So in the third part we'll do the first two part and also use an external interrupt which is to set the LED whenever the external interrupt is there. So this is the same, but for external interrupt we have used external interrupt 1 here. So the in ISR it will look for this location. We have not used 0, as for 0 it is 0003 for the ISR, and there is already data in 0003 in ISR. As we can see, we are starting at org00 SJMP start, so this will take the location for that, and org this instructions. So we are using this location external interrupt 1. As you can see, we are using the external interrupt 1. We can see that I have changed the value of I here to 86. The timer values are same as the frequency is same. Here I have added in one more variable, which is LED, and the LED I have cleared every time this for instruction goes. So this is the same JB in skip which we did for the last time. Now let's run and check if we can change 3 values at the same time. Setup, sometimes it gives error, so you can just do this, it will come again. Now I have added the 3 variables here. Let's run and check. See, we can see that the wave is there. Let's check the frequency. Frequency is around 5. Yes. So this is done. We can see now. Let's start again and see if we are changing this, then we are getting the P1.2. We can see that output is toggling inverse, right? Now for external interrupt, we'll give the external interrupt to the port 3 at the 4th pin. We can give this. We can see that LED is on. This on off is there because of the level trigger, but we'll see that this in actual will not be able to identify if the LED is getting on off continuously, as the frequency of this is very high. So yes, this was our sixth experiment for MCA subject. Thank you.